So this is your lecture number 2 of electrostatics, and today we'll be discussing about quantization of charge, right? See, chapter number 1, okay? In the previous lecture we had discussed about introduction to charge, different units of charge, and it can be measured with the not measured, but presence of charge can be detected by the device known as gold leaf electroscope, right? So these were the things we had discussed in the previous video. So today we'll be discussing about quantization of charge. See, quantization. First of all, what do you mean by quantization? Quantization means not continuous, not continuous. Discrete, we can say discrete. See, in the first lecture, we discussed that body can be made positively charged by removing electrons from the body, right? If you want to establish a charge of say 1 microcoulomb, then you have to remove the electrons accordingly in order to establish a charge of 1 microcoulomb. Now, suppose, let us say, let us take one glass rod. Let us say this is a glass rod, okay? Glass rod, and let this be silk. This is silk cloth, and this is your glass. Before any kind of process, both this glass rod and silk cloth are electrically neutral. They are electrically neutral. That means both will have equal number of plus and equal number of minus. Now suppose I am rubbing the glass rod with the help of a silk. Hmm? That means glass rod is rubbed with silk. Okay, so it is found that glass rod will lose few electrons, or we can say that electrons will be transferred from glass rod to silk rod. As electrons are loosely attached to the glass rod, so electrons will be transferred from glass rod to silk rod. Okay, now as glass rod is losing electron, so glass rod will become positive charge, right? Glass rod will have positive charge, will gain positive charge, and this electrons will be received by silk cloth. Since electrons are negative charge, so silk cloth will be negative charge. Okay, so one thing is sure, when you are rubbing glass rod with the help of silk cloth, glass rod is losing electrons, and so it will be positively charged, whereas silk cloth is gaining few electrons, so it will be negatively charged. Okay, fine. So basically, there is a transfer of electrons from glass rod to silk. There is a transfer of electrons from glass rod to silk cloth. Now, see, suppose suppose glass rod silk cloth. One electron is transferred from glass rod to silk cloth. So glass rod will gain 1 e positive charge, silk cloth will gain 1 e negative charge. Clear? Here, suppose 2 electrons are being transferred from glass rod to silk cloth. So glass rod will have plus 2e charge, silk cloth will have minus 2e charge. But it is never possible that glass rod will be losing 2.5 electron. Is it possible? No. No, that is never possible. Glass rod will never be able to lose 2.5 electrons, right? And silk cloth will never be able to gain this 2.5 electrons. Silk cloth will receive electrons in the multiples of E, and glass rod will be able to lose electrons in the multiples of E. That means glass rod can lose 3 electrons, silk cloth will gain 3 electrons, and so on. That means positive charge on the glass rod or negative charge on the silk cloth will not have all the values. It cannot have all the values. See, make it clear. glass rod can have either value 1e, 2e, 3e, 4e, 5e. In general, charge on glass rod will be Q equals to N. This is quantization of charge, where N will be, of course, 1, 2, 3, 4, dot, dot, dot. It will not have the value 1.5, 1.6, 1.7, 3.45, etc. Is it clear? That means charge on the body, glass one, right? Glass one. So charge on this body, charge on the body can never have all the values, right? Can never have all the values. If glass rod is losing 3 electrons, it will have 3e positive charge. That is 3 into 1.6 into 10 raised to minus 19. So that is 4.8 into 10 raised to minus 19 coulomb. Okay. If a glass rod is losing say 10 electrons, then it will have 10 into 1.6 into 10 raised to minus 19 coulomb. Clear? But it can never have charge of say uh, 3 into 10 raised to minus 19, 3.3 into 10 raised to minus 19, sorry. Clear? So charge on glass rod cannot have all the values. It will have it will have the values in the multiples of e. That is what quantization is. That is why the name is given quantization, not continuous. That means charge on the body is always quantized. Charge on the body is always quantized. Clear? See, charge on the body is always quantized. Quantized means not continuous. Charge cannot have any value. Body cannot possess a charge of say anything. Like suppose 2.5 e. This is not possible. 3.234 e, not possible. So charge on the body cannot possess all the values, and that is why the name is given quantization. Clear? That means it is not continuous. So finally, charge on the body will be equals to Q equals to Ne. This is the formula of quantization of charge, where N will be the number of electrons which are being transferred, from one body to another. Clear, students? Okay. Now, see one more thing. We discussed that charge on the body cannot have all the values, and it is clear that yes, because a body cannot lose 2.5 electron, body cannot lose 2.7 electrons. Okay, those facts are very clear. So if the question is being asked that charge on the body is always, we will take it as quantized. Charge on the body is always quantized. But one thing is again that quantization of charge is neglected. We are neglecting the quantization of charge at macroscopic level. Macroscopic means very large in number. Macroscopic level. Because see in the later on of the chapter we'll understand that we'll take all the values of charge. We'll not take only the quantized value of charge. We'll take any value of charge. That means we'll take that charge on the body is say 3.5 coulomb. We will take as 4.7 coulomb. So then you will be thinking that how these values of charges are possible, because as per quantization rule, these are the values a body cannot have. These are the charges a body cannot have. Clear? But that is what I am going to explain. Quantization of charge is neglected, and we'll take charge as continuous. Actually, charges are always quantized, but we are ignoring this quantization and we are taking each and every value of charges. The reason is, suppose I want to establish, I'm taking a body A, I'm taking another body B. Suppose I want to establish a charge of say 1 microcoulomb on a body A. I want a charge of 1 microcoulomb on a body A. So one thing is clear, if I want a charge of 1 microcoulomb, positive charge of 1 microcoulomb on body A, then I need to remove few electrons from body A. I need to remove electrons from body A. So how many electrons are needed? to be removed in order to establish a charge of 1 microcoulomb. So we'll use this formula Q equals to NA. Okay. So Q 1 microcoulomb. So 1 microcoulomb. So 10 raised to minus 6. N we don't know. Electron 1.6 into 10 raised to minus 19. So finally number of electrons will be 10 raised to minus 6 upon 1.6 into 10 raised to minus 19. So this will be 0.625 into 10 raised to 19 minus 630. Let us say 6.25 into 10 raised to 12. So this many electrons are need to be removed from the body A in order to establish a charge of 1 microcoulomb. See, this number is very large. 6.25 to 10 raised to 0 means 12 times. Right? So it is not possible for us to use or to follow the rules of quantization. Right? That means we cannot be able to take 1 electron, 2 electron, 3 electron, 4 electron, because there are very large number of electrons which are need to be transferred in order to obtain a charge of say just 1 microcoulomb. Clear? Clear. Just as I'll give you an example, when there is a water flow, we will not be able to count the number of water particles, right? Because they are very large in number. We'll take them as continuous flow only. In the same way, these electrons are very tiny, and in order to establish a charge of 1 microcoulomb, this many electrons are need to be transferred, which are very large in number. So we'll take charge as continuous and will not take it as quantized. Is it clear, students? Okay, if I'm drawing many dots but very close to each other, clear? So it may appear to you as a line. That means actually it is not continuous, but we'll take it as continuous. The same thing is for quantization of charge. Actually, charges are not continuous, they are quantized. Clear? But we'll take continuous values of charges. Students, is it clear? So if in the question you have been asked that is charge on the body quantized, then definitely we'll say yes. Charge on the body is always quantized. But we'll consider it to be continuous. Charges on the body are always quantized, but we'll take it as continuous. Then clear? Now let us talk about quark. Quark. Quarks. Quarks are very basic or very fundamental particles of which protons and neutrons are made. Protons and neutrons are made up of more fundamental particle known as quarks. Even though quarks don't have independent existence, they will appear in pairs only. There are different types of quarks, just as up quark, down quark, charm, strange, top, bottom. So these are examples of quarks. Clear? Suppose let us take it as proton. So proton is made up of 2 up quark and 1 down quark. This way. So up and down quark, they will occur in pair. So composition of proton is UUD, up down. This can be asked as an MCQ. What is the composition of proton? Up down. Up quark, it is having a charge of 2 by 3e. Down quark, it is having a charge of minus 1 by 3e. So see, this composition is U plus D. So that is 2 by 3e plus 2 by 3e minus 1 by 3e. So it is 4e by 3 minus 1e by 3. So it is 1e. Clear? Clear? Okay. Now, similarly, neutron is also made up of quark. Neutron is also made up of quark. Neutron is made up of UUD. Sorry, UDD. Neutron is made up of UDD. Electrons are not made up of quarks. Only protons and neutrons are made up of quark. So composition of neutron is UDD. This way. Up plus down plus down. 2 by 3e minus 1 by 3e. This is neutron. Got it, students? Electrons are not made up of quarks. Finally, Your quantization of charge is completed. So now in the next lecture, we'll be discussing about the charging methods of the bodies, right? Mainly there are three methods to charge a body, which we'll be discussing in the next lecture. Thank you.